Good morning, everybody. Welcome to today's webinar, customer training webinar. My name is Clint Walker. I'm the installation manager here out of actually snowy Ohio this morning. Winter finally arrived, I believe, in our area. But today's training webinar for the customer training webinar is about fan sizing, CFMs, and roof vents. Basically, proper requirements for your grain bins, even before we even put our equipment on the bin, kind of what to expect out of your scenarios, out of your process at your own sites, and maybe helping out with any future plans of what's needed on the grain bins or any additional equipment that can go on grain bins, maybe to help out with airflow, CFMs, anything that you're trying to do along with that. So today's date, obviously Wednesday, February 24, 2016, and we'll go through the training webinar here. We'll open up the phone lines at the end of the webinar and answer any questions about these topics that we talk about today. So let's go ahead and get started. So today we're going to cover the basic principles of grain storage. We're going to touch on that a little bit because it's important when it goes to speccing out the bins for what you want to do, depending if you want to change the quality or change the moisture of the grain, or if you're just looking at changing the temperature and doing aeration only. So that's we're going to start with that. Next, obviously, we're going to go into the natural air drying and the aeration principles, kind of the good rules of thumb of what's required for fan horsepower, roof venting, everything that goes along with that for what we want to do and what your process is at your location. We're going to talk about CFMs, what it is and how it's calculated. We're going to talk about fan sizing and the different calculations that go along with that to make sure that you have the proper fan size, horsepower, maybe the number of fans on your bins for what you want to do. Roof venting recommendations. Obviously, that's very important. Anytime that you're pushing air in from the bottom, moving air through, you got to let that air escape off the top. And then maybe a little bit of efficiency, obviously, with our controller once the bin is set up properly for what you want to do on how our controller can help with that whole process. So there's many reasons why grain deteriorates in the bin or spoils, however you want to say that. But the one that we're going to talk about today is high moisture or temperature, which usually is based off of inadequate airflow because you're not able to get the moisture or the temperature front pushed through in a timely manner before that grain goes out of condition. So that's the one we're going to focus on today. Everything else, obviously, the ones below it, obviously, are issues that can cause grain to deteriorate, but the one we're going to talk about on this webinar today is the very top one highlighted in red. So airflow, what it is. So obviously, depending on how much airflow you have is going to depend on how fast you can change that moisture or temperature front of the grain inside the grain bin. So once you put that grain in the bin, obviously the clock starts ticking on how long it'll keep. There's a storage life chart, which we'll show here in a little bit, for all different grain types. And obviously the higher the moisture, the higher the temperature, the faster it'll go out of condition. So we always have to keep that in mind. And when you're sizing your equipment on your grain bins, it's important to keep that in mind to have it sized properly so that you meet those criteria so that the grain doesn't go out of condition for what you're dealing with. So to store the grain, obviously you must control the temperature and moisture of all the grain. You have to push that moisture front or temperature front from the bottom to the top in an efficient manner, efficiently, and at the same time quickly in some applications if it's high moisture or high temperature so that you beat that clock of deterioration. You need lots of airflow. If you're changing the moisture of the grain, you need lots of airflow to get the grain dried down before the shelf life of the grain runs out. The amount of grain depth, or basically the height of the bin, affects the amount of horsepower you need to overcome the static pressure. So we're going to talk about static pressure and how that relates in and how we record that and why it's important to record that of the different grain depths as well and the different heights of bins that you guys have probably on your farm applications. And then as the static pressure gets higher, the CFMs decrease, meaning the higher static pressure, the higher the grain depth, the less the air can get through, and that air is starting to actually be able to dissipate right back into the fan, and the static pressure goes up and the efficiency of the fan goes down, because that air that you're trying to push in is so great and there's so much pressure underneath the floor that it actually gets pushed back out the fan, so the efficiency of the fan goes down as well. So that's very important to always know what your static pressure is and know exactly on how many CFMs per bushel you have in your application. So here's an example of a storage life chart. This is a corn example. But if you look at the storage life chart, we have the different moistures across the top. So the moisture of the grain going across the top. This is the temperature of the grain going down. So some customers, obviously, that we have, that you may go in with some wetter grain, it's a full natural air drying bin. If it's a wetter grain and higher temperatures in the fall time scenario, the storage life could be in the single digits before you have to change that moisture or temperature of the grain to gain more days to be able to hold that grain for a longer period of time. Our main focus, obviously, and to help you guys realize as well, is that your bins have to be equipped with the right airflow and roof venting and the right CFM per bushel to be able to get this moisture and temperature change in a quickly type manner, so that you can get into the yellow or even the green area to store that grain for a longer period of time. So, like I said, with higher moisture, higher temperature, like I said, the storage life is very minimal. As we get that moisture down or cool that grain off, then we can gain days, and then we have some more time to work with it, and obviously eventually hopefully get that grain dried down and cool down, and that's how we're able to store that grain for a long period of time. I literally have customers, and we actually have all of our installers and sales reps actually in-house this week, and they've talked to customers like yourself, and some of these guys have stored grain more than a year now, and trying to play that market if they have that total capability. So that's how they're able to do it. They're able to control those moisture fronts and temperature fronts with our equipment, maintain that good quality, and maintain that temperature and moisture throughout the bins. So the natural air drying principles, all right? So when you want to change the moisture of the grain, and I'm talking changing any type of moisture, it's ideal to have at least 1 CFM per bushel. Now, we know customers that don't quite have that, all right? We're not going to say that your system is not going to work at all right? It's just going to take you a little longer to do it. The less CFMs you have per bushel, the longer the time is going to take. So just for a quick rule of thumb, if you had 1 CFM per bushel, depending on what you're doing, on how much moisture, whether it's moisture or temperature you're trying to change, whatever time frame that would take, let's say it was going to take 3 weeks to change that moisture front from the bottom to the top. If you have a half a CFM per bushel, it's going to take you twice as long. It's going to take you 6 weeks to do that. So just a good rule of thumb, kind of what to expect for airflow of what your situation actually has. But the more airflow you have, the faster you can change it, the more capabilities you have, and that's why when we're helping guys spec out their bins, and we don't sell fans, we don't sell grain bins, this is where your local dealers come in to play, wherever you buy your grain bin equipment. We work with a lot of your dealers probably in your area. They might even be dealers of our equipment. But at that same time, between them and us, we can help guide you to make sure that you have the proper airflow on your bins, the proper roof venting, so that you have good airflow, depending on whether you're setting it up for natural air drying, or maybe you don't need as much airflow if you're just doing storage only and aeration. So that's the key to find out what you're doing in your process. And then you want to start those fans as soon as there's 12 inches of grain depth on the floor. All right, start those fans early. Once you have enough grain on the floor so that it's not going to blow over any floor supports on any situation, you can start those fans once there's about a foot of grain depth, and start that moisture front changing if you're trying to change the moisture of the grain, the natural air drying method of what you're doing. All right, so start them early. Allow the controller to overtake and control the fans when it's beneficial for the grain. Making sure that we don't run when it's too dry conditions and shrink the grain on the bottom. We don't want to do that, obviously, and run when it's really, really high moisture days, really high humidity days, where you're not really changing the moisture, or maybe even add moisture back to it of what you don't want to do. So that's the whole key with the BULLSEYE controller too, is to make it more efficient to run at the proper times of the day when it's beneficial for the grain. Allow the controller to operate the fans when it's beneficial for the grain, and the amount of fan runtime hours will depend on the grain type, the weather conditions, and how many points of moisture you need to remove, okay? So if you look at, I actually pulled this out of a natural air drying book that we have that we refer to quite often, but there's just three different grain types here. Just to kind of give you an idea, maybe if you're running into these type of moistures or you're putting these type of moistures in the bin, what's ideal or what's recommended for airflow for each one of these grain types for these different moistures. So if you look at yellow corn, all right, if you had 20 to 22% moisture corn going in the bin, you want at least 1 CFM per bushel. Now, if we're going closer to 22 to 24, once we get up to that 24 range, we need 2 CFM per bushel, all right? If you go back to that storage life chart, the reason why it requires more CFM per bushel is because the storage life chart on that really high moisture grain is very minimal, a lot less than a 22%, so that we need more airflow to get that moisture changed quicker, to get that moisture out of it, to cool it down, to have more storage life. That's why we need more CFM per bushel. Then we look at soybeans, just for an example, 16, 18%, 1 CFM. Once we get up to 20% soybeans, if you ever go in the bin it's that wet, we need 2 CFM per bushel, and so forth. Same for wheat, 14 to 16% wheat, we need 1 CFM per bushel ideally, and once we hit 18%, 2 CFM per bushel, and so forth. So this is kind of a good rule of thumb of what we look at for what you're dealing with. And we have customers actually that go in maybe with 24% moisture corn starting out. I mean, they'll hit a field early when they first start harvest, and they'll put some really wet grain on the bottom of the floor, and they may only fill their bin half full. If their bin is spec'd out for 1 CFM per bushel when it's completely full, if they fill their bin half full, then they have 2 CFM per bushel ideally, because they have half the grain depth. And so they initially put that wet grain in the bin. They have 2 CFM per bushel. It allows that moisture to come out of the grain quicker because they have more airflow. They get that initial moisture throughout that entire grain mass down to at least 22 or less, and then they can put 22 or less on top of that. So that's how guys are able to kind of tweak their system or have some capabilities, you know, maybe of if they do run into a wet year, if they have the bin space to kind of circulate some grain around and keep more airflow. So that's how they're able to do it without having a bin that's rated for 2 CFM per bushel clear to the eave, which is almost unlikely, you know, whatsoever, because your static pressure would be too high. So that's what they're looking at. That's how we're able to do it for what we're dealing with in any application, and help you guys get the equipment on the bins with what you're dealing with. So now when it comes to the aeration principles, all right, so the guys that are just mainly changing temperature, you're going into the bins at the right moisture already. You're not trying to change the moisture. You're just trying to take the temperature in and out of the grain, store that grain. This is the aeration principle. So the grain must be dry typically, all right? We don't want any wet grain in there that you have to change the moisture, because if the bin is set up for their aeration principles, you have a lot less airflow, meaning less horsepower, less electricity that you have to burn. So you're not changing the moisture, only temperature. Usually when they're speccing the fans out per bushel, it's going to range probably 1/4 to 1/10 of a CFM per bushel for airflow. So instead of a 1 CFM per bushel of what we want for natural air drying, changing the moisture, now we can be 1/4 CFM or 1/10 of a CFM when you're completely full, and obviously it's less horsepower for what you need on the bin just for changing temperature. So at the above CFM, so if you was running 1/4 to 1/10 of the CFM per bushel, it would take approximately 150 to 200 hours of fan runtime to change a temperature front, to push one temperature front through. So if you was changing the grain temperature, let's say on our controller, and having the controller help you do that, which would be more efficient than just running them manually so that you don't screw up the moisture when you're trying to change temperature. But if the controller was operating the fans, and let's say you have a target temperature on the controller set at 45 degrees, for instance, and you have an average grain temperature of 60, and you want to cool all the grain down, the average grain temperature down to 45 degrees, it would take approximately 150 to 200 hours, if you have this kind of CFMs, to change that 60-degree grain temperature down to 45-degree grain temperature throughout the entire bin. Hopefully that makes sense, I guess. Just kind of give you a ballpark of how long it would take just to change a temperature front only. So grain quality can never be improved in the bin, all right? And I think that's the biggest thing that we try to broadcast to guys, meaning if you put poor quality in the bin, we can't improve that quality, all right? We might be able to take the moisture out, or maybe put a little bit of moisture in, but the actual quality of the grain, the discounts that you'd receive at the elevator for the actual quality of the grain, that can never be improved, all right? However, it can be maintained. We can allow it with our equipment to maintain that quality so it doesn't get any worse, all right? It just comes from the moisture, the temperature front that we can push through. A lot of times with our spreader to be able to help spread the fine so you don't have those fine pockets and issues of hot spots and everything that can even deteriorate faster. So we can tie our equipment in for that. But that's the main point, is that we can maintain it for whatever you put into the bin, and that's key as long as you have your bin set up properly, especially for whatever you're doing with airflow and the right equipment on that. So just by adding a controller to your grain bin does not make it a drying bin, meaning if you have a grain bin that's set up for aeration principles only, meaning 1/4 to 1/10 of a CFM, that doesn't mean that by putting the controller you're going to be able to change the moisture of the grain throughout the entire bin in a timely manner. Now, that doesn't mean that you can't change it either. It's just going to take a lot longer to do it. You have to store that grain for a long period of time, several months, to try to change that moisture because your airflow is so low. We have customers that do that, but they have a long-term market strategy and be able to do that. But at the same time, they're not putting really wet grain in the bin either. They may only be changing the moisture maybe 1 point to 2 points max. And if you go back to that storage life chart, there are several days, as long as you keep it cooled down as well, that you can store the grain for a long period of time. But that's the biggest thing. When we put our controller on the bin, we're going to make your situation more efficient no matter what we do, all right? So before we even put our controller on the bin, we want to bring this information to you, what we're talking about today, knowledge to you, so you know exactly what your bins are capable of before we even put our equipment on the bin. What your airflow is, what your bins are set up for, if it's set up for natural air drying, what depths are set up for natural air drying, if it's set up for just aeration only, just because of the fan airflow is less. What you need to know for reasonable expectations for your equipment on the bin before we put our equipment on there and make it more efficient, okay? Because like I said, we don't want to change your process. If you already have it set up for your application, your process of your farm, we don't want to change that. You guys already know what, for the most part, what you're doing, all right? You spend a lot of time, I mean, that's your main bread and butter. And we don't want to change our process, but we want to make the best capabilities and you aware of what you have, because we will, with our equipment, make your system more efficient for whatever you're doing. So when we get to CFM, so CFM stands for cubic feet of air per minute, all right? We're going to talk a lot about CFMs. We already have a little bit. But when it pertains to the grain industry, or for what we're dealing with for grain bins, we're talking about CFMs per bushel, okay? CFMs per bushel is the amount of airflow through a mass of grain. That is calculated by the grain depth, based on how tall the bin is, the grain depth that you're going to be storing the grain at, the horsepower, how many fans, the total horsepower that you have on the bin, and the static pressure. All right. Now, static pressure has to be monitored somehow. All right, and we have two ways to be able to do that. And I'll get to that here in a second. But what I want to bring to your attention, and you guys may already know this or where to get this information. I put this up, and this is just an example of a Brock fan, just because I had the literature in my desk and was easy to get to. But you can go to any manufacturer of whatever fans that you have on your grain bins at this time and get any of these airflow rating charts for whatever you have for fans, whether it's an actual fan or a centrifugal fan, low speed, high speed. You can get these charts for your manufacturer. But I just want to show this just an example of what we look at. So when we help you guys determine of what you have for airflow, first of all, we're going to look up on a chart for the manufacturer of what you have for a fan, and we're going to, hopefully, with our equipment already on the bin, we're going to be able to monitor that static pressure. If we know the static pressure, and we're going to know the horsepower of your fans because that's already on the bin, then we can calculate, or we know exactly on how many thousands of CFMs your fans are putting out in your grain bin. So, for example, now this is an actual fan, so usually it's less static pressure. You see these empty columns here, and what this means is that if you had, let's say you had a 2 horsepower actual fan, once you get to 4 inches of static pressure, so this is inches of static pressure across the top, this is the different horsepowers, like I said, for a Brock fan setup, the different horsepowers and the model numbers of those. But if you have a 2 horsepower Brock axial fan, once you get to 4 inches of static pressure, that fan is pretty much stopped airflow whatsoever. There's so much static pressure there that it can't push any more air. All that air that you think you're pushing in is actually being dissipated right back out the fan. So that's why it's critical and crucial to monitor that static pressure, okay? But on any type of situation, we don't want to have too high a static pressure because as you look on these charts, the airflow goes down tremendously the more static pressure. So like I said, that static pressure is calculated off the grain depth and the horsepower. So that's when it comes to sizing your fans properly. You don't want to have too much fan, because if you have too much fan, then you have too much static pressure, and you think just because you have more fans, more horsepower, you have more airflow. Well, that's a lot of times not the case. There is that sweet spot or that happy medium to where once you go over that, then you're really actually just burning more electricity and really not gaining a lot of airflow, which I'll kind of show you maybe here in a little bit of an example of what we're talking about. So if you had a 10 horsepower axial fan and we was showing that you was reading, 2 inches of static pressure, you'd be putting out 12,840 CFM, total CFMs, okay? If you, let's say it was a 15,000 bushel bin, then you would do the division, and then that would calculate your CFMs per bushel. So that's how we record that. It's a very simple way. Once we know your horsepower and once we know your static pressure, we can see exactly what you have for CFMs by looking at one of these charts for your manufacturers of the fan. So that's an axial fan. Then we go for a low-speed centrifugal fan. So usually the low-speed centrifugal fans now can usually go at higher static pressures on some models, obviously as you go with higher horsepowers. But it'll put out more airflow. It's made for taller bins, all right? So if you had for this example, let's say you had a 20 horsepower low-speed centrifugal fan, and we was reading 4 inches of static pressure, let's say when your bin was completely full, you would have 17,000, just a little bit over 17,000 total CFMs. Do the division with the total number of bushels in your bin, calculate the CFM per bushel. High-speed centrifugal fans. So usually the only time high-speed centrifugal fans are used, and you look at what their capabilities are with static pressure, the time that these are used are really tall silos, really tall grain bins where you're going to have a lot of static pressure, and we still need some airflow at those higher static pressures. So this one goes much higher static pressure than what a low speed does. Low speed pretty much cuts off at 10, even lower on some models. These go up to 20 even on the higher models. So it's made for really, really tall grain bins on the commercial side, or really, really tall farm bins, concrete silos, something that's usually tall and skinny, or very tall amount of grain. But if you look at this chart, and I'm not going to go back to it essentially, but if you looked at this chart, I guess a good rule of thumb, if with that last example, I used a 20 horsepower low-speed centrifugal at 4 inches of static pressure, we was putting out 17,000 CFMs on a low speed. This one only has, 8,000 or 8.5, or 8,500 or 8,600 CFMs or total CFMs. So if you notice, the high-speed centrifugal fans put out pretty much half the airflow of what a low-speed centrifugal does. So that's what we can help spec out too for what your bin size is. Usually a smaller bin or farm bins, or anything you're trying to change the moisture or anything on the farm, most of the time you're putting low-speed centrifugals on because you get more airflow out of those type of fans, almost double the airflow is what you would for a high-speed, to where you'd need double the horsepower of a high-speed. So you need 40 horsepower instead of just 20 on a low-speed, and that's how guys can help save money by burning less electricity and less horsepower. So here's the calculation that I'm talking about. So let's say the bin capacity, level to the eave, was 60,000 bushels. And on that bin, he had two 20 horsepower low-speed centrifugal fans. And once that bin was completely full, we was reading 5 inches of water, or basically 5 inches of static pressure, when the bin was completely full. So that calculation that I was talking about, there's this. I captured this off that fan chart that we just went over. So the 20 horsepower low-speed centrifugal at 5 inches of static pressure, one 20 horsepower fan, is almost 16,000 CFMs, a little bit under that. But we have to double that because he has two 20 horsepower fans. So double that airflow, and we get 31,668 CFMs. That's the total CFMs over that entire bin when the bin's completely full. His total capacity, 60,000. We talk about that, so we told him 60,000 bushels. So when he's completely full, he has 0.53 CFMs per bushel. Takes its total CFMs divided by the total bushels, calculates the CFM per bushel, 0.53, or basically a half a CFM per bushel. All right? So that's how we calculate it. What you want to do, whether you're changing moisture or aeration, what's the right fan sizing, this is where we can calculate that from those charts. So for natural air drying, rules of thumb, most fans put out 1,000 CFMs per horsepower. It's a good rule of thumb to say, okay, for every horsepower, it's going to put out 1,000 CFMs. So if we had a 20 horsepower fan, essentially it'd be putting out 20,000 CFMs or very close to it. And different fan manufacturers are a little bit different, just by the fan blade pitch and what their fans are set up for. But if you had 20,000 CFMs for 20,000 bushels, that would be 1 CFM per bushel. A quick division, kind of like what I just showed you. If you had 20,000 CFMs, 20,000 bushels, a 20 horsepower fan would be good for 20,000 bushels to have 1 CFM per bushel. That's kind of just a good thing you can keep in your mind, just as a quick rule of thumb of kind of an idea what you need for horsepower. So we've talked about it before, the static pressure gauge, why it's important, what we do to read it. So we actually have 2 different models of static pressure gauges that we sell, usually with our equipment, or we put them on the bins just to kind of give you an idea even before our equipment so that we can help size those bins with the fans and everything appropriately before we can put our equipment on it. We have an analog style that we still sell. It's an analog gauge that screws right into the below the floor, the plenum area, right below the floor, and we can record that static pressure. That static pressure is obviously going to go up as the grain depth increases. So as you fill the bin, the static pressure goes up because it's a larger mass that the air has to be pushed through. And now, within the last year and a half, 2 years, we've carried what I call an onboard static pressure setup. And so a lot of our controllers that's already on the bins, they will actually set up so we have what I call a digital static pressure or onboard static pressure, and we read that into the controller. So we always have that documented now, and we can actually view it on the controller screen, and we can view it on the 80-link screen. We use it not only just to read static pressure and baseline static pressure, but we also use it for troubleshooting as well. If we don't see static pressure when the fans are supposed to be on, then obviously there's possibly an issue that the fans didn't actually turn on, maybe a blown fuse, pop breaker, thermal overload, whatever, but we can use a lot of it for the troubleshooting side as well. So any of the controllers that are out there that actually have an analog style but want a digital static pressure gauge so that they can read it there, all of our controllers are upgradable to be able to read that information. So that's the great thing about it. But we want to, of some sort, we want to be able to read static pressure. I don't care what model you have, we want to read it at some point so that we know exactly what airflow you have. So the deeper the grain, the more horsepower you'll need. Ideal grain depth when you're changing the moisture, or basically natural air drying, we're specking out, or we're helping spec out the fan horsepower and the depth at 20 feet grain depth. Once you go over 20 foot of grain depth, then the static pressure goes too high or higher, and your airflow starts tapering off. All right. So when we tell guys, if you want to change the moisture of the grain, ideally, if you're going to set up a bin for natural air drying, we're going to look at a 20 to 25 foot sidewall height bin. Doesn't mean you can't have a taller bin. Just means that once you go over that, it's not ideal to be able to change the entire moisture in a timely manner across the entire bin. But we have commercial elevators. We have large farm bins that are able, that their bins are 50, 60 foot tall or even taller. Doesn't mean they can't change the moisture of the grain. They're probably not going to change the moisture of the grain over the entire bin unless they leave it in there for a long, long period of time. They might be able to change the moisture of the grain maybe a quarter of the depth or a third of the depth, or maybe just help eliminate the shrink alone and not have that extra shrink loss in the bottom. So that's how we're able to make it more efficient with our equipment. And so like I said, once we go over 20 feet of grain depth, you need a lot more horsepower to overcome that static pressure of what those charts we just looked at to be able to keep that airflow up and what you need for what you're doing. So for an example, so these are, I guess a good way to explain it is these are two 10,000 bushel bins, holds the same amount of bushels, but one is 36 foot diameter and 12 foot tall. The other one is 18 foot diameter and 50 foot tall. So the one on the left, to have 1 CFM per bushel, we'd be looking at probably about a 10 horsepower fan. Since they put out about 1,000 CFMs per horsepower, to have 1 CFM per bushel, it'd take about a 10 horsepower for 10,000 bushels. All right, that good rule of thumb we just talked about. The one on the right, since that grain is much taller and the static pressure is going to be much higher, to have 1 CFM per bushel clear at the top, we would need a 300 horsepower fan to be able to have 1 CFM per bushel. The problem with that is there's no 300 horsepower fans made out there, all right? And your static pressure is so high anyways at the top that it's just not feasible. It's not realistic, right? So you would need 30 more times of airflow in this bin compared to this bin to be able to do the changing of the moisture, all right? Now, what that means is this is a natural air drying bin, or could be set up for a natural air drying bin with the right airflow. This one is more set up for an aeration bin, all right? But that doesn't mean that you can't fill this bin 10 or 12 foot tall and have a 10 horsepower fan on it and do natural air drying at the very bottom and then just put dry grain on top of it. That's what we have some guys do as well. It's just the realistic expectations of what you should expect for what your bins are set up for. Horsepower, grain depth, everything with comes back to CFM per bushel. So we can run a lot of calculations, and this is just one of our fan programs that we're able to get our hands onto, that we can actually help you guys just kind of give an idea of the time it's going to take. We can actually input a lot of these numbers. Like I said, we didn't come up with this calculation whatsoever. A lot of the bin manufacturers have these for their airflow charts, basically to help spec out the fans. And then on this calculator, it actually has kind of an idea of what it would take time frame wise. So just kind of a drying calculation, kind of give you an idea of how long it would take. So this is a 48-foot diameter bin. Sidewall height of the bin is about 25 feet. It's corn, so you can actually select the grain type. And like I said, it's a calculator. We can help you out. This is what our sales reps or customer service reps can help out. Your dealers that you can use. A lot of times they'll have the same calculator to be able to help you out exactly what you're doing. But I just programmed in some bin specs. This bin had 2 20 horsepower low-speed centrifugal fans. All right. And you put in some temperature and humidity ranges, all right, and the beginning moisture of 20% and 15% of an ending moisture. And so this bin is set up when it's completely full, not quite 1 CFM per bushel, but pretty darn close. I mean, 0.94 is real close. We look at the total bushels that this bin has. It's 35,800. Total CFMs when the bin's completely full is 33,800. Static pressure, 6.21, which is not realistic, it is realistic. It's very feasible. You still have decent airflow, all right, with those two type of fans. So if you're going to take just a rule of thumb on just kind of give you an idea on how long it would take to dry that moisture from 20% down to 15%, it would take approximately 24, 25 days to do that. But that would be 24 hours a day, all right? So if you didn't have any way to control the humidity or control the Mother Nature, which obviously we don't, that's where our controller comes into. So it may have to run 24, 25 days, but it may take maybe a month and a half, depending on what Mother Nature throws at us. But our controller, whenever those conditions are such that it's ideally drying the grain or removing the moisture out, we're only running during those times of the day. So we're not just turning the fans on 24 hours a day and using really dry air and really high moisture air and then the correct air to where you actually run longer and get more variable moisture throughout the entire bin. We're always using the most consistent air only when it's beneficial for the grain. How many bushels it'll dry essentially per day if you're able to run 24 hours a day essentially, and hours to dry the bin. So this is just kind of a good rule of thumb, just kind of give you an idea. Usually when guys are setting up their bins for natural air drying, they're putting wet grain in the bin. Just as a good rule of thumb, I'll say, just kind of a good reference, I'll say it's probably going to take 3 to 4 weeks. As long as we have decent conditions, as long as it doesn't go below freezing conditions, everything that goes along with natural air drying, okay? That's just one example. One thing I also like, and we'll get into it here in a little bit, but it kind of tells you what is kind of required or what's recommended for roof vents, all right? This is a little less than what we would use for recommendations, but it gives you at least some idea, all right? Because roof vent is just as important as the amount of horsepower of the fans you put on the bin as well. So this is a drying calculation for a tall bin. So this is no more than using 48-foot diameter I calculated almost a 36-foot sidewall height bin, one 50-horsepower low-speed double inlet centrifugal, the amount of roof vents required. But what I like about this chart is that you can see the airflow, static pressure, the airflow per bushel, the CFM per bushel at each grain depth as you go increase that grain depth in the bin. So obviously when you start out, there's less static pressure, more airflow. And when we're looking at what your capabilities are, we would say probably at 22, 23 foot of grain depth you'd be able to do natural air drying because we're at 1 CFM per bushel at this line. Anything over that, now we're half a CFM per bushel. Can you change the moisture of the grain? Probably, but like I said before, if the bin was completely full, now your CFMs is cut in half down to almost a half a CFM per bushel. It's going to take you twice as long. All right, so this is a good chart that we display to a lot of customers just to show them what their bin specs are and what their capabilities are for static pressure and airflow at different grain heights. And so when we go into an aeration calculation, it goes back to what you need for horsepower. Remember, we talked about usually it's set up for a quarter to a tenth of CFM per bushel. So on this setup, which is exactly the same setup what I just showed you here previously, 48-foot diameter, 36-foot grain depth, instead of one 50-horsepower fan for being able to do some natural air drain changes, now you only need one 10-horsepower fan if you're just doing aeration only because you're quarter CFM when you're completely full. So you've saved 40 horsepower, less horsepower, less electricity that you're gonna accumulate if you're just changing temperature only and just moving temperature fronts throughout the grain. And then too much fan. I touched briefly on it, but some guys, when we get to them, if their bins are already spec'd out, let's say for 1 CFM per bushel or for whatever they're doing, whether it's aeration or natural air drying, if they're spec'd out for what they want to do at their facility, they sometimes think that if we just put another fan on the bin, if we need more airflow, we just put another fan on the bin. Well, what happens is if you put more horsepower, you break over that happy medium or that sweet spot. Once you have too much airflow, then your static pressure starts going much higher, all right? And if we looked at that airflow chart on a low-speed centrifugal for 20 horsepower fans, once we get up on a low-speed chart for low-speed fans, once we get up to like 8 or more, your fan efficiency and your horsepower and your CFM per bushel really starts dropping off. Yes, he has 1 CFM per bushel when he's completely full, but if I programmed in 2 fans on this type of setup, which I actually did on the first example, you're really not gaining that much more CFMs per bushel compared to the other one, and you can save less horsepower and probably have less static pressure and probably be just as well with maybe 1 less fan. So we can actually program them in and see where that sweet spot breaks over or once you go over too many fans. So roof venting. So this is pretty typical across the Midwest. You know, a lot of the roof vents are down by the eave or somewhere close to the eave and evenly spaced around the bin itself. All right. The biggest thing with roof vents is the air that you're pushing in from the bottom is going to tunnel to wherever the air can escape out the top. So wherever those roof vents are at the top, that's where the airflow, that's where the moisture is going to change in that grain mass. At this point, you're going to possibly have some trapped headspace temperature up here where the air is not going to escape, especially if you keep the lid on the bin and you don't have it open so you don't get rain and weather conditions blown into the top of your bin. So when we say roof venting, all right, first of all, we want to make sure you have the proper roof venting, but you also want to place them in the ideal places as well. This is not efficient, obviously, to have an open top grain bin, but to represent what we want to do with roof vents is try to simulate the best way to have an open top bin. Have those amount of roof vents spaced out all the way around the bin from the peak to the eave, and simulate so if you had no roof on it, that airflow would be consistent all the way across the bin from the center to the outside. That's what we want to represent. Obviously, we can't have a grain bin without a roof, but we can simulate that idea with roof vents when we place them on. So good rules of thumb for roof venting. You would want 1.5 square feet of roof vents per fan horsepower. That's ideal. If you're pushing fan airflow in from the bottom, you want to have that air escape out the top. That's ideal, all right? And a good rule of thumb, and not necessarily everyone follows it, but just kind of a good baseline is 1.5 square feet of roof vent per fan. So if we had a 20 horsepower fan and we want 1.5 square foot of roof vents per horsepower, we would need 30 square feet total of roof vents. Calculate that into inches, so multiply it by 12, so we need 360 inches of roof vents total. Let's say you had 18-inch roof vents, square roof vents, so you would need, you divide that by 18, you would need 20 18-inch roof vents for a 20-horsepower fan, ideally, to have 1.5 square feet of roof vent per horsepower. So since you're putting roof vents at different heights from the peak to the outside, those roof vents may not all be 18 inches in square. The ones that by the peak might be long, narrow ones. But overall calculating the total number of square inches of all your roof vents, you want to kind of fall into that 1.5 square foot of roof vents for what you need. Something that can be very added, I'm not going to say added very easily, because obviously it takes some time to be able to cut roof vents in. Your dealer would be able to do that, or your millwright that's doing that. But it's a quick way, I would say, quick way to be able to change your airflow just by adding more roof vents, which is then going to cut down on your static pressure, which is then going to be able to have more CFMs per bushel. It all ties together just by doing that type of simulation. So remember the first picture just had the roof vents down by the eaves. Now that simulation, what we want to use to try to get that airflow across the entire bin from the center to the outside, there's literally 3 layers of roof vents. One towards the eave, one intermediate, and then the peak as well. So that air is simulating the best way to do it, to still be able to have a roof on the bin, but yet have that air tunnel to all those roof vents from the peak to the eave at that point. That's ideal for setting the bins up. Another way to capture that is not only just roof vents by themselves, but powered roof exhausters, so be able to help pull that air out and help exhaust that air out. A lot of larger bins, whether it's large farm bins or even large commercial bins, they use powered roof exhausters. And obviously that can help with your CFM per bushel as well, because you're helping pull that air out of the top and help circulate that air, which then cuts down your static pressure. They can be automated to help. The great thing about it is we can actually automate those into our controller, so we can automate them to read the headspace temperature and then just run them individualized by themselves without running the bottom fans, just to keep the headspace cool. And that helps without, so you don't have condensation, the drip, like throughout the spring and summer where the grains cool down and it's hot temperatures outside and the headspace temperature warms up tremendously throughout the spring and summer. We can just run those roof exhausters automatically from our controller by reading the temperature at the headspace and reading the grain temperatures, and then help keep that headspace cooled down. So it works really well with our controller for our separate program that we have on that. And like I said, it helps with that roof condensation and avoids that top layer of crust on the bin of something that you would have there, which obviously we want to totally avoid. All right, we're all about grain quality. All right, we want to make sure that you get the same grain quality of what you put in. All right, we don't want to have that grain deteriorate whatsoever. Especially with the market that we're in at this point, grain prices lower, the ability to have a loss at this point is much more drastic than when the prices are elevated and have a little more wiggle room. All right, we don't want to lose money at either point, but it's much more critical at this point as well. So we've talked a lot about what your bin should be set up for when it comes to horsepower, roof vents, calculating CFM per bushel, what your expectations are for your equipment. And then when we put our equipment on the bin, then we make it more efficient, all right? So typically, if you're going to run the fans 24 hours a day, and I hear a lot of producers that tell us that, they're running their fans 24 hours a day, let's say for 2 months straight, and by 2 months in, before they go into the winter conditions, they say, well, my grain moisture should be dried and my temperature should be cooled down and ready to go into winter storage. Well, that's typically true, but the problem with that is they usually have an uneven moisture front from the bottom to the top. Might be too dry in the bottom. They've shrunk the grain, or have that shrink factor. Right in the middle might be right what they want for a target, and at the top might be still not quite dry, maybe because they didn't run their fans long enough or their CFM per bushel wasn't high enough to be able to push that moisture front all the way throughout the entire bin. So that's the whole idea with our equipment, so that when we run the fans, we get that even moisture from the bottom to the top, all right? We can do that with our controller. We have that outside air temperature sensor and outside relative humidity sensor off the bottom, and being able to know what the moisture of the air outside, so that when you're running your fans, we can keep that consistent moisture front of what you want for a target pushed from the bottom to the top and be able to adjust the settings if you start seeing it go in a direction that you don't want, moisture-wise or temperature-wise or whatever. We have a lot of capabilities for what we want and keep that uniform moisture from the bottom to the top. We have a lot of producers, especially with specialty-type grains, that want a specific moisture, maybe because they get premiums paid on within a range of specific moisture. And it doesn't matter if it's specialty-type grains or not. You don't want any discounts if it's too wet or the shrink and get discounted because you have loss of weight. We have the capabilities to equalize that moisture from the bottom to the top, whether you're just changing the moisture or changing the temperature and not allowing the shrink on that side of it as well. So that's how our equipment ties into it. That's how we can make your equipment on your bin that you already have specified, spec'd out for what you want, that we can help you out with, or your dealer can help you out with, and still maintain the quality and store that grain for that storage life chart of what we looked at for long periods of time to be able to play the market or to manage your grain for your marketing strategy as well. So we do have discounts still available. I believe we still have, for another month or two, we still have discounts on our equipment over the winter. We use those winter discounts, very typical of what bin companies do as well throughout the winter months. So if you have any questions on that, definitely visit us at AgriDry. Contact your local dealer that is possibly an AgriDry dealer, or if they're not an AgriDry dealer, have them communicate with us, and we can possibly set those guys up as a dealer, someone locally that you're dealing with or that you're used to dealing with to help you out on that as well. So if you have any questions whatsoever, don't hesitate to call us here in the office. Get a hold of our sales reps. We have sales reps and service reps throughout the entire country in your areas as well. You can visit our website at agridryllc.com to get a lot of that information, get the contact numbers and names of those customers, of our people in your local area, as well as our dealers. We actually have just modified our website so it shows the dealers in your area as well, so to let you know who's a dealer for AgriDry equipment as well. Our phone number here at the office is 1-855-AgriDry or 419-459-4399 is another main contact number that you can reach us here. So if you have any questions about anything, whether you have our equipment or not, don't hesitate to call us on that. We can help you out in those type of situations of anything that we need about our equipment as well. So I'm going to go ahead and open the phone lines just to briefly touch on anything that we covered today. If you have any questions about CFMs, fan sizing, or roof vents, and I'll open the phone lines. I'll let you know when they're open. Ask any questions at that point, and after that, we'll end the webinar so you guys can get on with the rest of your day. So let me open the phone lines. All right, guys. I think the phone line should be open. If you have any questions, go ahead and ask them now, and we'll try to answer them here while we're on the phone line here about what we just talked about.
I have a question.
Absolutely. Go ahead.
Running temp cables in the bin. I've got the temp cable set so that I know what the grain temperature is, but there's probably some temperature readings coming from the top of the bin. Can I use those are those active temperatures that I can read the peak of the bin, the empty space in the bin, so I don't get condensation?
Do you have powered roof exhausters on your bin at all, or you just have the bottom fans on your bin?
Just bottom fans with roof vents.
Okay, so the guys that do not have powered roof exhausters, obviously we can't use that automated program. However, in your situation, to get an accurate average grain temperature, so that you're always reading an accurate average of what you actually have of the grain mass in the bin left, whether you pull some grain out of the bin or maybe didn't fill it all the way or whatever the case is. On our system with our controller, you have the capability for however many cables you have to be able to select or deselect what sensors are in or out of the grain. You do that by marking an X either on the display. If you have a communication package, it's very similar. You put a checkbox on what sensors are actually in the grain. But by doing that, whatever ones are selected with an X or a checkbox takes it into the average grain temperature. The ones that do not have an X on it or are not selected, it will still read them. And you can actually show on the controller if you want, if it will still read them. So when you go into on your controller or your communication, it will show your average grain temperature, which will be the accurate grain temperature because you selected which ones are in the grain. And then going through those individual temperatures, it will show you the other sensors that are out of the grain. It'll still read them. Just by on-checking them, it does not take it off the screen or doesn't stop reading them. You'll still be able to read those other sensors to see what your headspace temperature is as well, to where if obviously with power roof exhausters, you're able to help control that headspace. Usually, like going in the spring and summer months, typically that headspace gets very warm, and so your grain temperature still cool down. And to help control that headspace temperature, we try to engage just roof exhausters by themselves. Don't we really want to warm up the grain on the bottom, essentially, because we want to change the temperature on the bottom. We still want to keep it cooler, but at the same time, we can just circulate that air at the very top. But yeah, you would be able to consistently see that on, I don't know how many temperature cables you have in the bin, but you'll be able to see what your headspace temperature is of the deselected ones and then the grain sensors as well, and kind of see what your variance is of temperature for which ones are in or out of the grain.
Yeah, if you've got a 10-degree difference between what the grain temperature is and what the headspace is, do you think you would have a moisture problem or not?
10 degrees is slight. Once we kind of get to like 15 degrees or more, think of a glass of water, on the patio table, you might say, when that condensation starts to form on the outside. I think we usually say about 15 degrees or more. 10, maybe not quite, but yeah, once we start going up from there, 15 degrees or more, then it's definitely conductive, or the opportunity for condensation is definitely there with that temperature differential for sure.
Okay, thank you.
You bet. Is there any other questions while we're on the line? Well, hopefully, like I said, this webinar is going to be recorded, all right? So you guys can always refer back to it if there's something that maybe went over too quickly, or if you ever want to refer back to it. It's definitely going to be recorded, and we'll be able to be seen on our website and a link from our website to go back to it. Hopefully I answered all your questions. If not, guys, our phone lines are always open here in the office as well. So don't hesitate to call us here in the office at the numbers we talked about earlier. Any of your local dealers that are in your area that sell our equipment, contact those guys. If they don't have the questions, I'm sure they'll get in contact with us and or our local sales or service reps throughout the entire area for your area. So don't hesitate to call us on anything that you come across as well. We definitely want to make sure if you do have our equipment that you are getting the benefits and the efficiency out of our equipment as well. So we want to help you out on any aspect. So I want to thank everybody that was able to take the time out of their busy schedule here today to join us. And like I said, it'll be recorded so you can refer back to it at any time. And like I said, thanks again. And if you have any questions and anything, don't hesitate to call us. I appreciate your time, and look for upcoming webinars as well. We'll have a few more here within the next month or two, and feel free to join on those as well. Appreciate it. Thank you, guys. Have a great day.